Practice test 5. There are 28 questions in this practice set. I'm going to do non-repeated question. This is question number 1. Rewrite each equation as requested. Rewrite as a logarithmic equation. So this is exponential form. As you can see here, the base of this form is 5. So this 5 goes here. That's a base 5. The value 25 goes here. So the log base 5 of 25 is equal to this exponent value, which is 2. So from here the base is 2, so the base goes here. The exponent comes from the other side of the equation, which is -4, and then value comes from here, which is 1 over 16. So 1 over 16, 2 to the power -4 is 1 over 16. So remember, this is the the conversion relation. If you have let's say y equal a to the power x, then in log form you can write down log base a of y equal x. So if you want to go from exponential to log, then find out what is the value of y, a and x and plug the value here. And same if you want to go from log to exponents. Great. Okay, one more time. This is also the very similar problem. The base is e, and then you want to rewrite this as a log equation. So by using the very same fact, remember log base e means ln. So when you try to write down log base e, y is 2 here, and x is, as you can see here, x is y. So when you try to write down this would be y equal ln 2, and then here the base is e. So e, because ln means it's a log base e. Okay, e to the power 6 is equal to x. Okay, so find out the value of log base 4 of 1. What is the value of log base 4 of 1? And what is the value of log base 6 of 1 over 36? So by using the very same fact, you would like to find out, let's say this is the expression you have given, x equal log base 4 of 1. You would like to find out the value of x. How do you do that? By going to the equivalent form in exponential form. So from this equation, rewrite this exponential form. So from here you can see that y is 1, a is 4, and then x is x. So solving this or finding the value of this is actually solving this equation. 1 equal 4 to the power x. For what value of x? 4 to the power that would be 1. There is only one possibility, that is 4 to the power 0. Okay, so that means 4 to the power 0 gives you 1. So the value goes here is 0. Log base 4 at 1 is 0. And here, by doing the very same thing, what is that? By doing the very same thing, you can find out one more time. X is equal to log base 6 1 over 36 can also be written as 6 to the power x equal 1 over 36. So finding the value of this, which is finding the value of x, is equivalent to solving this exponential equation. Here is the 6 to the power x on the left side. Rewrite this 1 over 36 as 36 to the power 1, and we know 36 means it's a 6 square, and there is a -1 here, so you can write it down as 6 to the power -2. So because the base are same, so x should be equal to the -2. If the base of the equation are same, then exponent has to be same. So the answer for this one is negative 2. Here is the graph of ln of x. You would like to find the graph for ln x plus 1 plus 3. X plus 1 means the graph goes 1 unit to the left. So this goes 1 unit to the left. And then plus 3 means everything shift 3 unit up. So goes 1 unit left and then 3 unit up. Remember, x plus 1 means it's a horizontal shift to the left. Whenever you see the plus, it's a horizontal shift. And plus 3 means it's a vertical shift. So always keep in mind, you do the horizontal shift first and only after that the vertical shift. Okay, we would like to plot the graph for log base half of x plus 4. So first of all, you have to know the graph of log function. The graph of log function, and then after that you can find the graph of it's log base half x. Negative 4 means it's shifting down 4 unit. Plot 2 points on the graph of the function and also draw the asymptote. So the asymptote for the log function is vertical line. So this vertical line, and then you would like to put the 2 points as well. So first of all, find the point when x is 1, the value of log is 0, because log for any base at 1 is 0. Remember, the log function is the reverse of exponential function. So to find the points, what you can do is x and y is negative 4 plus log base half x. Make the table. When x is 1, y is negative 4 plus, find out the value of log base half of 1, which is 0. It's negative 4. So the value would be 1, negative 4. Now because the base is half, now you can find when x is half, because if they have the same base and same number, the value would be 1, right? So when x is half, the value of y would be negative 4 plus 1, because log base b of b is 1. So here the base is half, so I'm trying to find out the value of this log function at half, which is 1. So that's going to give me negative 3, and that's going to help me use this point. At half the value is negative 3. So these are the 2 points I'm going to use. For that, just use here when x is 1, the y is negative 4, plot that. And when x is half, y is negative 3. 2 points are enough. We're asked to use 2 points. And the vertical asymptote would be this one. Okay, the vertical asymptote. Now to plot the graph, this is the graph. You see? Check. Great. So you just need to find out the points by using this function, and then you have to make sure that what is the vertical asymptote look like. Here there is no horizontal translation, that's why the vertical asymptote would be x equal to 0 line. But if you have horizontal translation to the left or right, you have to change your vertical asymptote accordingly. Okay, in this case the domain of the function, remember always the domain of the log function, whatever function you have, log 5 minus x, whatever comes inside this parenthesis, to find the domain of the log function you have to make that greater than 0, because the domain of the log function should be always positive. Now you have to solve this equation. So if I just add x both sides, that gives me 5 is greater than x, meaning the domain of this function is less than 5. So if 5 is here, then the domain would be anything from the left side. So from negative infinity to 5, that's the domain. X is less than 5. X is less than 5 means starting from negative infinity to 5, not including 5, that would be the domain of this function. So use this negative infinity, and then here is the 5. Okay. So here we can use the difference rule, here the sum rule, here is the power rule. The difference rule means if they have the same log with the same base, then you have to divide 3 by 5. So it would be log base 4 of 3 over 5. Okay. So here is the sum rule. 7 times what gives you 28? 7 times 4. And then finally, this negative 2 goes to 5 to the power. So, you have to go over the properties of the log function. This is the power rule. 5 to the power negative 2 is 1 over 25. 1 over 25. Okay. One more time. The last problem I'm going to show you. Negative 2 log base 9 of 5 can also be written as log base 9 of 5 to the power negative 2, but 5 to the power negative 2 is 1 over 5 to the power positive 2, which is eventually 1 over 25. That's the power rule. Okay, use the property of logarithms to evaluate each of the following expressions. So here is you can apply this power rule first. So you can apply 2ln, oh no, you don't have to do that. Whenever this log and then their base come together, there is a one rule. Log base b of b to the power x is equal to x. In this case, the base is e, because ln stands for log base e. So whenever ln and e they come together, they will just, that's a reverse process. So the leftover would be the exponent times 4. Here it's negative 11, because ln e to the power negative 11 is negative 11 only. So it's 8 minus 11, which is negative 3. So the first expression, that's negative 3. The second one, because it's a minus, so it's a division. 18 divided by 3 is 6. So here it would be log base 6 of 18 over 3. Log base 6 of 6, because 18 over 3 is 6. So because they have the same base, the answer would be whatever you have on the exponent, where in this problem there is nothing, that means there is 1. So the answer is 1. Okay, use the property of logarithms to expand this, and each logarithm should involve only one variable. So you can go over the properties. I can just use product rule. So I can write down this as log z cube plus log y by using the product rule. Eventually there is a power, so I can bring that 3 in front of log function, and then I can write down this as this one. Remember, you have to read the instruction. They are saying they don't want any variable with the power, so you have to bring this 3 down here. So the answer is 3 log z plus log y. Okay, by doing very same thing here, first of all, this is log cube root. That means there is x to the power 7z over y squared to the power 1/3. You have to rewrite, you have to expand this without the power. So you first of all use the power rule, bring this 1/3 down here, and write down log x to the power 7z over y squared. because there is a quotient, so you have to use the quotient rule. So that is actually log x to the power 7 times g minus log y square. Read the instruction. It says each logarithm should involve only one variable. So there are two variables and should not have any radicals or the exponent. So as you can see here, there are two variables, so you have to expand this. There is an exponent, so you have to use the power rule. So since here is the multiplication sign, so we can use the sum rule. Log x to the power 7 plus log z minus this 2 comes in front by using the power rule, log y. So one more time, there is exponent 7, so you can bring this 7 here and you can write down log x plus log z minus 2 log y. So that's your final answer. 1/3 7 log x, okay, plus log z minus 2 log y. Let me double check, okay. 1/3 7 log x plus log z minus 2 log y. Okay, write the expression as a single log. So in previous problem we expanded. Now here you have to write down this single log. So as you can see here, you just have to go back from here to go back. So how can you do that? First of all, the first term I can write log base m w to the power 2, because that power can go to the exponent. And for the second part, there is a minus sign, so before I use the minus, I have to take care of this, the power, this 2, so I can write down this as a log base m y square. This is log base m w square plus 2, and this is, there is a minus sign now, then I can write it down as a log base m z over y square, and log base m w square, this 2 goes here by using the power rule, so log base m z over y square whole square. Now one more time, because here is a plus and they have the same log with the same base, I can write it down this as a log base m w square times this, which is z square over y square. Square means y to the power 4. So that's what I can write. So log base m, and here w square, and z square, no, z square divide by y to the power 4. Let's double check. W square z square divided by y to the power 4. Use the chain of base formula to compute log base 8 9. This is similar to the one of the previous problem we did. I don't, let me see which one. Okay, here the way we did number 3, you can do exactly the same thing for number 12 to find out this value. So I'm going to skip it. Write the equation in exponential form. So by using the previous problems, you can do the exponential form. Always write down your base, which is 3. So here the base is 3. The power comes from other side of the log equation, which is 2, equal x minus 2. X minus 2. So that's the exponential equation. Now, to solve for this equation, you can go to the exponential equation like this and solve for x. Just add 2 both sides, so that would be 9 plus 2 is 11. So the answer is 11. Okay, Now let's verify. Log base 3 of 11 minus 2 is log base 3 of 11 minus 2 means it's 9. And since we know log base 3 of 3 square is 2, so log base 3 of 11 minus 2 is 2. You see that? Log base 3 of 11 minus 2 is 2. That's the answer. So that's true. Okay, here we need to solve log equation, but always keep in mind, before solving log equation you need to find the domain for the log function you are using, because eventually you need to check either your solution is part of the domain or not. Here in this case there is only one log function we are using, and for finding the domain you just have to make this expression which is inside the parenthesis greater than 0, and now just subtract 9. That will be negative 8g is greater than negative 9. Divide both sides by negative. When you divide by negative, this sign flip to the other side, and that will give you g is less than 9 over 8. So the domain of the function you are using is any real number which is less than 9 over 8. So any answer after solving this equation, if it's less than 9 over 8, you can take that as your answer. If it's greater than 9 over 8, then you cannot take it as answer, because the domain of the function we are using here should be less than 9 over 8. Now after finding that information, we can solve this equation. How do we do that? First of all, if there is a log function, isolate the log function, meaning take this log function on the left side and bring log base 7, 9 minus 8g, bring everything else to the other side, so that means 31 minus 13, and after that just divide both sides by 9. Divide both sides by 9. That will be log base 7 of 9 minus 8g equal 31 minus 13 is, it's 18 divided by 9 is 2. Now solving this equation can be done by changing this log equation to the exponential equation. How do you do that? Write down this 9 minus 8z on one side, 7 to the power 2 is other side. That's how we are changing log to exponential. Okay, now solve for z. So to solve for z, first of all subtract 9, so that will be negative 8z equal 7 square means 49 minus 9 is 40, and now just divide both sides by negative 8, so z equal negative 5. So after finding the solution, go back and check the domain. Domain has to be anything less than 9 over 8, and negative 5 is less than 9 over 8. That's why you can take this as a solution. So this is negative 5. Remember, after finding your solution, you can go back here and plug the value for the z and then check either that gives you the right true statement or not. Okay, so here you have two log function. So first of all, bring this log function to the other side. So by doing that, you can write down this as a log base 3 4z minus 13 minus log base 3 z plus 13 equal 1. Before solving this log equation, you always have to find out the domain for the whole equation, and domain for the whole equation would be actually domain for the first one and then intersection domain for the second one. Intersection means whatever domain you take, that should be true for both of them. So how can we find it? First, find the domain for the first one, which is let's say d1, domain for the first one, by making this expression greater than 0. Solve for z. So 4z is greater than 13, and if you divide by 4, that's z supposed to be greater than 13 over 4. That's the domain for the first log function. But we also need domain for the second log function, which is z plus 3 has to be greater than 0. So if you solve for z, that will give you z has to be greater than negative 3. Remember, after we find the solution, that should be true for both of them. That's why the domain for the actual equation supposed to be the intersection. Intersection means common between these two. So if you try to plot the graph for this, g is greater than 13 over 4. So let's say this is 13 over 4, which is slightly greater than 3. So for the first one, anything greater than this number is okay. But for the second one, anything greater than negative 3 is okay. So this is also pointing to the same direction. Remember, d2 is greater than d1. Greater in the sense, it is d2 has d1 plus some extra. But you cannot take this extra for the whole equation, because that extra does not satisfy the d1. So intersection of d1 and d2 is equal to actually d1, because d1 has a smaller region than d2. So the domain for the equation is anything greater than 13 over 4. You can only accept your answer which is greater than 13 over 4. Okay, so that's how you find the domain of the equation. After finding the domain, now you can solve this. There is a minus sign, so you can use the difference rule. So that equation can be written as log base 3 4z minus 13 divided by z plus 3 equal 1. This is a logarithmic equation. You can always change this equation to the exponential. So you can write it down this as 4z minus 13 over z plus 3 equal 3 to the power 1. So from log you can go to the exponential, and now you can solve for z. So there is a z plus 3, so we can just multiply both sides by g plus 3. So that would be like this, and now you have to solve this linear equation. Okay, so bring this 3z on the other side, subtract 3z, and then add 13. By doing that, this one gives you g, this one cancel out, this one cancel out. 13 plus 9 is 22. So z is equal to 22. And now you go back and check your domain. The domain has to be greater than 13 over 4, and yes, this 22 is greater than 13 over 4. So the exact answer, the solution set, is 22. Sometime you might get more than one answer, and your answer might not be inside the domain. In that case, you don't take that answer if it's not from the domain. Okay, this is very similar to the previous problem, so I'm going to skip it. Very same idea here, both sides log, so it should be 11 minus 9x equal 2x, and solve that equation. But before solving, you need to make sure that you know the domain. Okay, so the domain for the first one comes from here, domain from the second one comes from here, exactly the way I did number 15. You can use the same idea. It's remember, 11 minus 9x has to be greater than 0. You solve for x, so subtract 11, so negative 9x has to be greater than negative 11. Divide both sides by negative 9, but when you divide by negative, this sign flips, so x has to be less than 11 over 9. That's for the left side. From the right side, 2x has to be greater than 0. So your domain is anything positive but less than 11 over 9. So from here you can see this one says anything positive would work. So let's say this is 0. Anything would work from here. This one said, hey, I can't take anything greater than 11 over 9. So the domain would be intersection. Intersection means the common of these two. And you can see that the common of these two is from 0 to 11 over 9. So the domain for this equation is from 0 up to 11 over 9. You can have anything from here. Okay, And how do you solve this equation? Because both of them have the same log with the same base, so you can just say 11 minus 9x equal 2x and solve for x. So 11, if I add 9 both sides, it would be 11x. So x equal 1. You see, x equal 1 is from here. So the solution set is x equal 1. Okay, a very same idea. You have to find the domain for each of them and find the domain for all of them, which is after find the intersection, and then use the log property and solve like previous problem. Okay, solve for x in the equation below. So whenever you have exponential equation like this, you have to take log function both side. Based on this base e, if you take ln, then that would be easier. So by doing this, ln and e will be cancelled out, and the left side it would be 7x, on the right side it would be ln 6. If you divide both sides by 7, remember this ln and 6, ln is just a notation for log. There is no meaning of ln without this 6. Okay, so you have to write down ln 6. So the answer for this is ln 6 over 7. That's the exact answer. If you are looking for exact answer, this is what you are going to use. Round your answer to the nearest. First of all, find the answer. Round your answer to the nearest 100. So problem like this, if I use ln 6 over, can I type ln? There is no way I can type ln, so I need to use a calculator. Here is the calculator. ln is, what is that? Here is the ln, 6, and then divide this by, what is that, 7, and hit enter. That's your answer. Round your answer to the nearest 100, so that means 0.26. 0.2, there is a 5, but because after 5 there is another 5, so we round it to the nearest 100 is 0.26. Okay, this is same thing. Okay, problem like this, if you have if you have exponential equation with a different base, you always have to take log function, either LOG or LN. So this is our problem number 20. There is a 7, 1 minus 6x, there is a 10, 5x plus 3. Because there is a base 10, I'm going to take LOG, 7, 1 minus 6x, LOG, 10, 5x plus 3. Remember, log stands for log base 10. So here is the base 10, here is the base, here is the 7. So I can bring this 1 minus 6x in the front by using the power rule, log base 7. Here the log has a base 10 and there is a base 10, so I can just write down 5x plus 3. Okay, if you remember this formula, log base b of b to the power something is actually that something only. So this b is 10 here. Now treat this log 7 as a number like 5, 3, 2, something like that, and then try to solve this. So what do? You first distribute this log 7. Do not worry about this notation, it's just a number. Minus 6 times log 7 x equal 5x plus 3. Now your goal is to solve for x. So if you don't see x on the term, then just bring that to that term to the right side, and then all the x terms to the left side. So here I'm going to subtract log 7, and I'm going to subtract 5x. By doing that, what I'm trying to do is I'm bringing all the terms with the x on the left side. So I'm just going to copy, because they are not the same similar term. Negative 5x, negative 6 log 7x. On this side, it's a 3 minus log 7. So to solve for x, first of all, you can factor out x, and it gives me -5 -6 log 7 equal 3 minus log 7. So what is the value of x? Just divide both sides by this -5 minus -6 log 7. -5 minus -6 log 7. So x is equal to 3 minus log 7 over -5 minus -6 log 7. So that's your answer. The exact answer is that this one, 3 minus log 7, 3 minus log 7, and -5 minus 6 log 7, 6 log 7. That's your exact answer. For the approximation, you just use your calculator. Okay, here is no calculator, so you have to use your handheld calculator. I'm going to just use scientific calculator from here. So this is what I'm going to type: 3 minus log 7, 3 minus log 7 parenthesis close, divided parenthesis -5 -6 log 7, -5 -6 log 7 parenthesis close, and hit enter. That gives me -0.2139, and round to 4 decimal place. So round to the 4 decimal place, it's a -0.2139. If you want to round it to the 4 decimal places, it would be 10, so it would be 2140, -0.2140. Okay, the exact solution set is this, and then this is the answer, 214. That's same thing. Okay, this is one of the application problem for the exponential function. As you can see here, there are two formula you have given. You have to use one of them. This is the problem. A $10,000 investment grows to $12,507.51 at 4.5% interest compounded quarterly. This is the hint. Compounded quarterly means you have to use the second formula. You use the first formula only if it says compounded continuously. If they say other than compound continuously, then you have to use the second formula. Okay, so in this problem we have to use second formula, which is A equal P times 1 plus R over N to the power N times T. Whatever formula you pick, you can only use that formula if you know all the notation except one. Okay, so in this case, find out all the information, and one unknown thing is not given here. So this $10,000 investment grows to $12,000, so that means the principal is 10,000, and then amount in the future, A is 12,000, so it's a 12,507.51 equal 10,000. 1 plus the rate is 4.5%, which can be written as 0.045. Always you have to divide this number. Whenever you see the percentage, divide that number by 100 and write down that. And N means how many times in a year they are compounding. According to this problem, they are compounding quarterly. That means 4 times a year. So N has to be 4. And here, N times T, you need to find out for how long was the money invested. You need to find out the value of T. You know N is 4, and you need to find out the value of T. You can do this. You know this is the exponential equation. First of all, divide both sides by 10,000. 10,000. Cancel out. You can use your calculator here. Okay, and now to find out the value of t, you can just take ln both sides because you have to bring this t down. So I'm going to take ln. I'm not going to do a calculation here. I'm just going to, keep it like this because I don't want to round the answer in the middle, and that is the instruction they might give you. The money was invested for approximately, look at here, round to the nearest year. Do not round it in the middle of the calculation. If you take ln both sides, this 40 comes in the front and you have ln of 1 plus 0.045 over 4. So now to find the value of t, just divide both sides by 4 times this expression, ln 1 plus 0.045 over 4. 4 times ln 1 plus 0.045 over 4. So by doing that, you can find out the t. Now I'm going to type everything on my calculator here. It's a ln. Where is ln? Ln. What is the number? 12,507. 12,507.51 divide. You have to be careful with this parenthesis. 10,000. Parenthesis close. And there is a divide sign again. Give another parenthesis. 4 times ln. It's 1 plus 0.045. 1 plus 0.045 divided by 4 parenthesis close. If you do not type it, the way I'm typing, then your calculator is not going to give you the right answer. So you have to put this division sign, multiplication sign and parenthesis appropriately. Otherwise, it's not going to give you the right answer. So your answer is 5.000085, which means if you round it to the nearest whole number, round to the nearest year, that would be 5 year. Round to the nearest year, that would be 5 year. Okay? The tricky part here is how to use your calculator. If you don't know how to use your calculator, then you have to spend some time on it. Okay? Type this thing properly. Okay? So that's your question number 21. 22, one more time, this is exponential equation. You have to find the value of t, plug the value of y and y0, and then for this particular problem, I'm going to give you what is y and y0. The amount of money invested in certain account increases according to the following formula. This is the formula you're going to use. After how many years will the initial investment will be doubled? So remember, y0 is initial investment here, and y is the final amount. We want this y 2 times y0. Double means 2 times initial value. So when you try to use this formula, you put y equal 2 times y0. Though you don't know what is y0, it doesn't matter because you are going to cancel this y0 because both of them have the y0 on the both sides. So just divide both sides by y0. So eventually this is the equation you would like to solve, you see, for finding the time. And if you take ln both sides, ln2 equal ln e 0.015t. Because ln and e are inverse of each other, it gives you 0.015t. And for finding the value of t, just divide both sides by 0.015. And that's going to be your time, ln2 over 0.015. So to find the answer, you have to use a calculator. ln2, what is that? ln2 divide by 0.015. Hit enter. That's the answer. After how many years will the investment will be doubled? Do not round any intermediate computation and round your answer to the nearest tenth. So nearest tenth would be 46.2 46.2. After 46.2 years, the initial investment will be double using that formula. Okay, for each system of linear equation given here, classify the system as a consistent, dependent, consistent, independent. So here L1 and L2, they are same line, so they are dependent, they are depending. Consistent means you can find the solution because there are infinite solution, and they represent the same line, so it's called consistent dependent. And then solution is infinitely many, there is no one solution, there are infinitely many solutions. Here, because they are parallel line, they are inconsistent, meaning there is no solution, there is no intersection, so no solution. Here it's consistent dependent, sorry, this is consistent independent, this is consistent, sorry, this is consistent dependent, this is consistent independent. Independent means there are two different lines, but there is a one solution, and that solution is this point of intersection, which is 3, 3, 3, 3. So if you're talking about the same line, it's called consistent dependent. If you're talking about two different lines but there is a one unique solution, that's consistent independent. If there is no solution, it's inconsistent. Okay, solve this, graph the system, then write its solution. So first of all, plot the graph for y equal x plus 6. It's just a line, so I'm going to put when x is 0, y is 6, when x is 1, y is 7, if that point is available. If that point is not available, then plot this one, these 2 points. Okay, for second one, when x is 0, the y is 4. I'm just putting x equals 0 here, and by using this second formula I can find the y. And when x is, let's say, 1, y is again 5, so I can just join these 2 points. You see, do you see any point of intersection here? The solution is no solution because both of them, they are parallel lines. Here use the substitution to solve. So substitution method is, you have to solve for one variable. The one variable is already given from the second equation. X is 3y minus 9. I'm going to substitute for x here in the first equation, which is 5 times x plus 3 times y equal negative 9, but x is 3y minus 9. That's called substitution here. And distribute 5, 15y minus 45, 5 times 3, 5 times 9, plus 3y equal negative 9. Now combine the like terms. 15 plus 3 is 18y, and bring this 45 to other side. So that gives me plus 45 minus 9 is plus 36. And if you divide both sides by 18, y would be 2. That's the solution for the y. And now we can find the solution for the x by using this x. 3 times 2 minus 9, which is 6 minus 9 is minus 3. Always check your solution. Check. Go back here in the first equation, put x equal negative 3 and y equal positive 2. That would be negative 15 plus 6, which is negative 9 equal negative 9. So that means that's the right answer. So the answer is negative 3 and positive 2. This is also solving system of equation. You can use addition method here, because substitution is a little bit difficult. For using the addition method, you have to make opposite coefficient for one of the variable. If you look at the variable x, for the first equation there is a 4, and for the second equation there is a 2. So I can multiply the second equation by negative 2 and make the opposite variable for the x. So if I multiply this second equation by negative 2 When I multiply, I have to multiply both sides. That gives me negative 4x positive 14y equal negative 22. So I'm going to use this thing here, negative 4x positive 14y equal negative 22, and now I'm going to add these two. That's called addition method. By adding here, you can just cancel this positive and negative 4x, and that's going to eliminate the variable x. And if you add negative 3 and positive 14, that gives you 11y equal negative 11 on the other side, and if you divide both sides by 11, that will be negative 1. After finding the value of one variable y, you choose one of the equation and put y equal negative 1. I'm going to choose the second one, 2x minus 7 times negative 1. For finding the value of x, positive 7 equal 1. Subtract 7, that would be 2x equal 4, and then divide both sides by 2, so that gives me x equal 2. After finding the value of x and y, put that value in the first equation to check either that is the right one or wrong one. So I'm going to skip that part. So x equal 2 and y equal negative 1. But remember, always if you want to make sure 100% that your answer is right, you have to check this answer by plugging this value back in the equation. Okay, you can find the solution, or if you don't have the solution, then you can choose one of the answer here. If you look at this equation, x plus 4y plus 8 equals 0, and then second equation, if you multiply both sides by negative, it will be x plus 4y plus 8 equals 0. So both of them are the same equation. So the system has infinitely many solutions, and you can write down the value of y. So if I just use the second equation, which is negative x negative 4y equal negative 8, and if I multiply both sides by negative 1, that gives me x plus 4y equal positive 8, right? Oh, sorry, I was wrong. This is the equation I get from the second one. And from the first one, x plus 4y, if I bring this 8 to the other side, it's a negative 8. So look at here. The very same x plus 4y in the first equation is positive 8. The very same x plus 4y in the second equation is negative 8. That's not possible. So that means the system has no solution. For the second part, if you look at the second part, system B, first equation x plus 2y equal 2. And second equation, if you multiply both sides by negative, it also gives you x plus 2y equal 2. That means they represent the same equation. So here because they are same equation, they have infinitely many solutions. So what is the value of y? You can pick this equation and find the y. Just bring x to the other side. 2y equal negative x plus 2. Divide both sides by 2. Y equal negative half x plus 1. So that's the value of y. Negative half x plus 2. That's the solution for the y. Sorry, plus 1. Okay, and this is your last problem number 28. This is application problem for the system of equation. Carlos, the trainer, has two solo workout plans that he offers his clients, plan A and plan B. Each client does either one or other, not both. On Wednesday, there were 5 clients who did plan A and 6 who did plan B. On Thursday, there were 3 clients who did plan A and 2 who did plan B. Carlos trained his Wednesday clients for a total of 12 hours and his Thursday clients for a total of 6 hours. How long does each of the workout plan last? So problem like this can be solved by changing this problem into system of equation. So for example, here we have to find out the two information, length of plan A and length of plan B. So let's assume that X represents it's a time, which is length for plan A, and Y represents time for plan B. Now we have to express all this information in terms of equation. So if you look at here, first one, on Wednesday there were 5 clients who did plan A. So for one client, if it takes X amount, for the 5 clients it's a 5 times X, and 6 who did plan B, so it's a 6 times Y. Okay, so all together, if you see here, on Wednesday there are 5 clients who did plan A and 6 clients who did plan B. On Thursday there were 3 clients who did plan A and 2 who did plan B. Carlos trained his Wednesday client for a total of 12 hours. This is the total hours for the Wednesday. And for the Thursday, there were 3 clients who did plan A and 2 plan B. So 3x, 2y, and altogether Carlos spent 6 hours. So these are the system of equation you are planning to solve. Okay, how do you solve it? By using the addition method. Here you can see that there is a 6, there is a 2, so I can multiply the second equation by -3, and I can make it -9x, -6y, -18. By doing that, I create the opposite coefficient. So I'm going to copy this first equation down here, +5x, +6y, +12, and I'm going to add these two equations. That's called addition rule. By doing that, I can eliminate one of the variable y. So -9 plus 4 is -4x, -9 plus 5 is -4x. This is cancelled out. -18 plus 12 is -6. So if you divide both sides by -4, that gives the time for workout for plan A, which is x equal 3/2, which is 1.5 hour. Okay, now we go back and choose one of the equation for solving for y. Put x equal 1.5 hour in the first equation. Let's say this one. On Wednesday, Carlos spent total 12 hours, right? 5x plus 6y equal 12. And for plan A is spent 5 times, this x is 3/2, which is 1.5 hours, 6 times y. We're just plugging the value of x, 15/2, 6y equal 12. 15/2 means it's a 7.5. So subtract 7.5 from both sides. That gives us 6y equal 12 minus 7.5, which is 4.5. So divide both sides by 6. So y equal 4.5 divided by 6. 4.5 hours divided by 6. So remember, 4.5 hours means in minutes because it's less than 1 hour. So first of all, I'm going to find out 4.5 hours if you multiply divide. Where is that? 4.5 hours divided by 6, that's actually 0.75. So for plan A, the answer is 1.5 hours. For plan B, it's a 0.75 hours. So these are the value for x and y. So you can always solve this type of problem by changing the problem into system of equation. Okay.